This week's topic is on sampling. Sampling is the process by which we're selecting our observation or selecting our participants for a study. It's not always possible to collect information from all the people or units in which we're trying to study. For example, if we're trying to study assaults in Minnesota, we may not want to go out and survey every single person within Minnesota. Obviously, it'd be almost impossible to do that. Or scaling that down a little bit, it's often not necessary to collect data from everyone out there. A lot of times we may want to look at assaults in a portion of a city. Well, it may not be necessary to go out there and interview or do whatever we're doing for that study, whether it be a survey or an experimental design or whatever. And we don't necessarily need to talk to every single person that is experiencing that possible phenomenon to see if it's occurring or not. Sometimes we can take a random sample or a small subset of people or observations, and we are able to possibly generalize it to the rest of that population if we take a good random sample. In previous chapters, we've talked about generalizability being this almost dirty word for reliability. In regards to reliability. And what we mean by that is taking a small finding within a population and generalizing it to other populations. A good probability sampling will take a representative sample. It means that each member of the population has a known and equal chance of being selected. So this is a little bit different when we talk about generalizability. Not all populations are the same in regards to variables, so we want to take a good random sampling to have a good probability of representing the study population. So in regards to our sampling, we need to be mindful of bias, whether it be conscious or unconscious. For example, what percentage of students have gone to a Bemidji State University game? Let's say we wanted to study that, so we decide to take a random sample of people that are living in the dorms. Well, let's say that 70% of the people living in the dorms have been to a Bemidji State football game. Well, is that representative of the whole school? Can we say in publications that 70% of Bemidji State students go to Bemidji State football games? No, because there's a lot of students that live off campus, there's a lot of students that might be online, there might be students that commute from a long ways away and have no interest in football. And, so maybe it's more 20% of students of Bemidji State go to football games. I couldn't tell you what the actual statistic is, but let's say let's say we do this study and we're conscious of our bias that we're only studying the people that are living in the dorms. When we go to report that statistic, we could say 70% of the people living on BSU campus housing living in the dorms go to Bemidji State football games. So that way we're letting the reader know our bias, and we're not claiming that 70% of all Bemidji State students are going to football games. So now let's say we are going to be doing a small scale study. Maybe our budget's fairly small, or there's some other factors, or we're just trying to get some preliminary data to find out a certain phenomenon in an area. So let's pretend that we're going to be doing a study on prison inmates within the Minnesota State Correctional Facility, and we'll pick one, let's say St. Cloud, and we're going to do a study on individuals with mental illness, and we're going to try to come up with an estimate of how many people have mental illness so we can pick from that sample to study the mental illness further within the prison system. So a sample element is who or what we are studying, so the inmates within the St. Cloud prison. The population is those people in the St. Cloud prison who have a mental illness. And the parameters we're going to put on that is they're going to need to be on medication, or they're going to either need to be in therapy, or have a diagnosis of a serious and persistent mental illness, such as schizophrenia, depression, and we'll have to define that more specifically, which actually is defined in Minnesota statute on what a serious and persistent mental illness is. And the sample statistic is then, once we find the sample element population and we have the population parameters, we're able to come up with a sample statistic, which gives us how many people within the St. Cloud prison that we estimate have a mental illness. And for example, let's say 20%. So 20% of individuals have a mental illness or a serious and persistent mental illness within the prison population. And then we now have a population, that 20%, in which we can take random samples of to study whatever phenomenon we want to study in that population further. So now we're looking at the basics of statistical data. And when we're looking at a sample, the larger the sample within our parameters, the more we can conclude that the sample is representative of the greater population. So a sampling frame is a list of elements in our population, and by increasing the number of samples selected and interviewed, increases the number or the range of estimates provided by the sampling operation. Now let's take a peek at sampling error. On this side is the vertical axis, which is the amount of samples we have of a certain population. And let's say that population is jail inmates, and we want to find out how many prior felonies they've had. So we're doing a survey with them or whatever. And down here is the amount of prior felonies they've had prior to their incarceration. So basically all we're doing here is the more people we have in the study, the more samples we have, the better estimate of the true average we're going to have. So in this case, the true average is 3 people, or 3 prior felonies. And if we're only examining 10 people, it might be, all around the clock here. But the more people we have in our study, the more we find out where that mean is. So if we're only studying 10 people, the average might be 4 people, or 4 prior felonies, I'm sorry. But the more individuals that we have, even if we go with 80, 100, 1,000 samples, the better estimate we're going to have of how many prior felonies, and in this case, the average is 3. So the standard error is how far people stray from the mean, and when we get that kind of data, we can better guesstimate on average how many, if we have just one person, we have to make an educated guess on how many prior felonies that person likely has. We would say, well, they likely have 3 based on our statistical data if we have a lot of individuals within our study population. But if we have a small sample, we would be off if we said 4 likely. We would just have a greater probability that we would be off of our guess. So 2 key components of sampling error are what level of confidence we have. So what level of confidence do we have that our mean is actually 3 in this case, and the specified interval from that parameter. So how far off are we going to be if we go with a lesser sample? So what is acceptable in our study? We might want a very exact study, so we're definitely going to want, in this case, to jump up to maybe a sampling size of 50 or more, because anything less, we're just too far all over the board, and we want a sampling size that is going to be representative of the greater population. And if we hit that 50, now we know that, okay, maybe this is a good sampling size. Just a rule of thumb is typically a sampling size should be at least 30 if we're going to get any good, reliable statistical data out of that study. So to summarize probability theory and sampling distribution, we need a random selection that permits the researcher to link the findings within a sample to the body of probability theory, so we're able to estimate the accuracy of those findings. And once we do that, all statements of accuracy in the sampling must be specify both a confidence level and a confidence interval. So a researcher must put a percentage on how confident he or she is that the population parameter is in between the 2 specified values. So there are different types of probability sampling designs, and they can be used alone or in combination for different types of research purposes. But the key feature of all these designs, these probability designs, are the relationships between the populations and the sampling frames. A sampling frame is a list of elements from which a probability sample is selected. So let's say we want to study the attitudes of prison wardens on the death penalty. So the sampling frame that we're going to use is the prison wardens and prison superintendents that are members of the American Counseling Association. So remember, we can't generalize this to all wardens and prison superintendents because we have a fairly narrow sampling frame because they have to be members of the American Correctional Association. And our population, though, is wardens and superintendents. So the population is wardens and superintendents, and the sampling frame is the American Correctional Association members that are wardens and superintendents. The next type of probability sampling is a simple random sampling. In a simple random sampling, once we have our study parameters set, that's what it is. It's just a complete random sampling of people that meet that study parameter. So let's say we're looking at the American Correctional Association, and there's 5,000-10,000 members, and we want to know what the attitudes are about a certain data set. We might want to throw all those people into a computer program, and that computer program, there's computer programs out there that will just randomly generate at complete 100% random people that for our study, so we don't have to contact all 5,000 to 10,000 people. It just randomly generates that. So systematic sampling are elements in the total list that are chosen. For example, so we have 10,000 people, say, in the American Correctional Association, and instead of putting them into our computer program, we might have a long list of them, and of all the members, and we decide to pick every 100th person is going to be in the study. So we're not randomly generating it, but we're just taking every 100th person on that list. Another example of this too is some of the students last week were talking about flipping a coin or doing dominoes or rolling dice and things like that to see if each person. But if is going to be in the study, or taking 100 people, and then you're just going to take the odd number of people, or assign them even or odd, and you just take the even or odd number of people into your study, or have even people go into the control group and odd go into the experimental group. So in some situations, it's going to be impossible to find a good probability sample. In the majority of the cases, having a probability sample is going to be beneficial over a non-probability sample, but there are some cases where a non-probability sample is recommended. For example, if we're studying the mind of the serial killer, we're not going to be able to randomly assess people typically because there just aren't that many of them. So a non-probability sample is a sampling in which the probability that an element will be included in the sample is not known. So we don't know how often this phenomenon is happening within this population. And the research in this can oftentimes generate themes for future research. It's really good with qualitative types of studies, but we can't necessarily generalize that to the larger population. There's a better probability of that when we use probability studies.